Hi class, and welcome to section 2, and today we're going to talk about straight line motion, so connecting position, velocity, and acceleration. So for those of you that have taken physics, this will be a really nice section where you can see how the two subjects overlap with each other. Okay, so when we study motion initially in calculus, we consider what is referred to straight line motion. When we study this idea, we are concerned with 4 concepts. So position, velocity, speed, and acceleration. As discussed earlier, notation for a position function with respect to time t is usually s of t or x of t if the object is moving along the x-axis, and y of t if the object is moving along the y-axis. Okay. So we're going to look at this first example. Okay, so I apologize, my dogs are being rowdy. I let them outside. Okay, so for example 1, I have s of t is equal to t squared minus 2t minus 3. So I want to show its position on the number line for t is equal to 0, 1, 2, 3, and 4. Okay, so what I'm going to do here is, if you're watching this from home, I want you to put this equation here in y1. Okay? The reason why I'm going to have you put that in y1 is then after you put it in y1, you're going to go, so if you need to pause the video, go ahead and do that. Then what you can do is you're going to look at the table. So that's just second graph. Okay? And you're gonna, therefore, now you can just look at the table and see, okay, well, what is the value for each of those? Okay, well, I know, so just going over at s of 0, okay, that is -3. So when t is 0. When t is 1, we get -4. When t is 2, we come back to 3. Okay, when it is 3, we get 0. And let me just put that in there. And at 4, we get 5. So if you were looking at kind of how this particle traveled, we went to the left, and then it goes right. So now let's look at velocity. When an object moves, its position changes over time. So we can say that the velocity function, v of t, is the change of the position function over time. Well, anytime I'm seeing these words, it's the change of, okay? You should be thinking of a rate, which means this is our derivative, okay? So we can say that velocity, and we kind of talked about this a little bit before, your velocity is the derivative of your position function. So that is really important here. And for convenience sake, we will define v of t in the following way, okay? Because when you do an AP exam, they're going to be asking you, okay, which direction is the particle moving? Is it speeding up? Is it slowing down? Is it stopped? Okay, so let's look here. If your velocity is positive, okay, so if you get a positive number when you plug it into that derivative of your position, that means that the object is either moving to the right or it's moving up. If your velocity is a negative value, that tells us the object is either moving left or down, okay? And if your velocity is 0, that means the object has completely stopped. Okay. So speed is not synonymous with velocity. Speed does not indicate direction. So we define speed as the absolute value of velocity. Okay, so the speed of an object must either be positive or 0. And think about it. If you're driving your car, okay, when you're looking at your speedometer, it starts at 0 and goes up. There's no negative numbers there. Okay. So the next thing we'll talk about is acceleration. The definition of acceleration is the change in velocity over time. We know this to be a derivative. So again, derivative there, you want to do here. So it's the change in velocity. So that means that your acceleration is the derivative of velocity. And since velocity is the derivative of your position function, we could also say acceleration is the double derivative of your position function. So super important to know there. So given a position function s of t, we can now determine both the velocity and the acceleration function. Okay. So on your cars, you have two devices that change velocity. What are they? Let's go ahead and guess what you think they are. Well, hopefully you got the first one because it sounds just like it. The accelerator, or gas, and the brake. Okay. So we're going to do the same thing that we did with velocity. We're going to define it as following. So if your acceleration value is positive, okay, that means that it's either moving to the right or moving up. If your acceleration is negative, so again, that means once I take the derivative of velocity, I plug in a number. If I get a negative value, that means it's either moving to the left or down. And if your acceleration is 0, that means your velocity is not changing. One thing that's really key with that is just because the object acceleration is 0, it does not mean that the object has stopped. It just means your velocity is not changing. So if you think about that, what device in your car will keep the car's acceleration equal to 0? And it's something that you use typically when you drive on the highway. Your cruise control. Okay. Also, just because you have a positive acceleration doesn't mean that you are moving to the right. So that's a little bit, because even though it says object accelerates to the right, it doesn't mean you're always moving to the right. So for instance, suppose you are walking to the right, so your velocity is positive, when all of a sudden a large wind started to blow to the left. So that means my acceleration is negative. What would occur? Okay. Well, for all those runners out there, we have a good amount of you, that would mean that, think about when you're running against a strong breeze. It doesn't mean I go backwards. It just means, unfortunately, I slow down. Okay. So let's go ahead and look at an example 2. A particle moves along the x-axis with position function s of t equals t squared minus 4t plus 2. Complete the chart for the first 5 seconds and show where the particle is on the number line. So one thing I want to do is I want to make sure I want to write what is my velocity function and what is my acceleration function. Okay, well, velocity is the derivative of my position function, so I have 2t minus 4. And acceleration is the derivative of velocity, so that is 2. Now, what I want to have you guys do is I want you to fill in the chart for the first 5 seconds and show where the particle is on the number line. If you have your calculator on you, this is a really great time to use your calculator. And I wish I had a calculator on my iPad so I could show you some tricks, but I will, if you were not in class, I will show you next time you're in class. But what you should do, again, you can plug it in and get every value, but that takes a while to plug and chug all those numbers with 3 different equations. So what I recommend doing here is in s of t, put this in y1. In y2, so after you put that in y2, okay, I want you to hit math 8, so that brings up the derivative. So then you'd have, so again, that's math 8. Okay, and then you have d over dx. Okay, then what you're going to do is you're going to hit alpha, and then you want to hit that F4 button up on the top. I think it's the Calc. And then hit enter, so you have, because it's going to bring up your vars, so you're going to hit y1, because that's going to take the derivative of your y1. And then it's going to go x equals, and then you're going to put x. Okay, so x equals x. That way your derivative will give you back, that way you're going to get specific numbers there. So again, when you're looking at the table, this will give, you'll look y1 here, y2 will go here. Now, you can do the absolute value for here if you would like. If you really want to, you can go to y3 and you can do the absolute value. So how you do the absolute value, you're going to hit math, and then you're going to hit 1 over to, it says NUM, and there you're going to just hit enter and it'll bring up the absolute value. So you'll hit absolute value, and then you're going to hit that alpha calc, I believe, so bring up F4. And again, that'll bring up your vars. And this time, instead of hitting y1, you'll hit y2. And then y3 will give you these. Now for the acceleration, it's always 2. So you really can just fill that part in. But if you want to, if it wasn't 1 like that, then I would just do kind of similar what I did with y2. So I'd go math 8, the derivative, and then I would hit, I want the derivative of y2, x equals x. And then that would give you all your values here, or sorry, this would be y4. But you can do this all in your calculator there. Okay, so go ahead, pause the video, and check your answers. Okay, welcome back. So I'm just going to go ahead and fill in these values. Okay, so let's actually now interpret this. So the description. So if I'm looking here, I notice my velocity is negative and my acceleration is positive. So what this is going to tell me is the particle moves left, okay, but then it's being pulled to the right because my acceleration is positive. At t equals 1 second, same thing going on. My velocity is negative, my acceleration is positive. So same thing. If this was an actual AP question, I would write it out again. But since these are just notes, I'm going to use those quotations to know that it's just the same. If you would like to write it all out, you can. Okay, let's look at 2. Well, at 2, I'm noticing the velocity is 0. So anytime that velocity is 0, the particle is stopped. Okay, so then let's go to the next one. The velocity is positive and the acceleration is positive. Okay, so that means the particle moves right and is being pulled right. And then that would be the same for t equals 4 seconds and t equals 5 seconds. So those are all the same. Okay. So the work we did, I will say in example 2 is a bit much. That's not how it's going to look on the AP exam. What I can do though is we're going to look at it a little bit more simply. So in general, we are concerned with what direction the particle is moving and when it is stopped and when it is speeding up or slowing down. So those are our big things that we want to make sure we look at. Okay, so what we're going to do is I want you to pause this video and then come back and I want you to fill out each and every one of these. So is it speeding up? Is it slowing down? Is it constant, or has it stopped? So again, go ahead, pause the video, and then come back and check your answers. Welcome back, everyone. Okay, let's see how you did. I'm just going to go ahead and abbreviate this. So if the velocity is positive and the acceleration is positive, this is speeding up. If the velocity is positive and the acceleration is negative, I am slowing down. And if the velocity is positive and my acceleration is 0, I'm at a constant speed. Okay, let's go to the next one. If my velocity is negative and my acceleration is positive, I am slowing down. If velocity is negative and acceleration is negative, I'm speeding up. And again, if velocity is negative and my acceleration is 0, that means I'm at a constant speed. And this last one, my velocity is 0, so that means I have stopped completely. So one thing to notate here is that if your acceleration and velocity are the same sign, then it's always going to be speeding up. So if you notice, when they were both positive or when they were both negative, I was speeding up. If they're opposite signs, then I know that it's going to be slowing down. Okay, so whether one's positive, one's negative, the other's positive, one negative, that's going to be completely for you. Okay. So determine intervals where particles are slowing down and speeding up. We generate a sign chart for velocity, a sign chart for acceleration, and a third sign chart, which we'll call motion, which is the product of the first two. Okay, so let's look at some examples. So determine the time intervals where particles traveling on a straight line, defined by each of the given position functions, are slowing down or speeding up. So the first thing I want to do with this problem is I need to find, well, what is my velocity and what is my acceleration? So my velocity, again, that is the derivative of my position function. So that is 2t minus 6. And my acceleration, remember that is the derivative of your velocity or your second derivative. In this case, it's 2. Just an FYI, you don't have to write this part here. This is just me reminding you in your notes how to find that. Okay, so I found my velocity, I found my acceleration. The next thing I want to do is I want to say, well, where are my velocity and acceleration negative at? Or sorry, not negative, but 0. So I'm going to go ahead and I'm going to set my velocity equal to 0. And again, why I'm doing that is I want to know when is the particle stopped? So I'm going to set it equal to 0. So I take 2t minus 6. I'm going to set it equal to 0, and I get t equals 3. Now with acceleration, my answer is just 2. So a of t, in this case, is always greater than 0. So it actually is, your acceleration is never 0 at this case. Okay, so what I'm going to do is I'm going to make a sign chart. It's a really great tip to use, especially when we go into the next unit, because we're going to be looking at where do functions increase, decrease, etc. So I'm going to make a little sign chart. No, let's go something like this. Okay, so here's 0. And I'm just going to put some values on here. Okay. So let's look, we'll start with velocity. Okay, well, velocity at 3 is 0. So I'm going to put a little 0 up here just to notate that. I'm going to do velocity on top, acceleration on the bottom. Now I'm concerned, okay, is it going to be positive or negative? So I'm going to pick a value less than 3. And an easy one is going to be 0. So I plug it into my velocity function. So I'm plugging in 0 into 2t minus 6. I get negative 6. That is a negative number. So anything to the left of 3 is going to be negative. Now we're going to do the same thing. I want to plug in and pick a value bigger than 3. For acceleration, well, acceleration is just always 2, so it's always positive. Or sorry, not acceleration. Your velocity, I'm going to plug it in there. So I plug in a number bigger than 3, I get a positive, and there we go. Okay, so now on the bottom, I'm going to go ahead and do acceleration. Well, acceleration is always positive, so this is all positive here. Okay, so now I can actually answer the question. So they want to know, when is it slowing down and when is it speeding up? So I notice that remember, it's slowing down when your velocity and your acceleration are different signs. So I know it's going to be slowing down. On the interval, negative infinity to 3, and then it's going to be speeding up on the interval 3 to infinity. And that's it. Okay, so what I'd like you guys to do now is I'd actually like you to do B on your own. So go ahead and pause the video. You're going to want to do the same thing. So find the velocity, find when the velocity is 0. Then go ahead and find the acceleration, find when the acceleration is 0. And then make your sign chart and then come back and answer the question. When is it slowing down and when is it speeding up? Okay, welcome back. So first thing we did is we found our velocity. So our velocity is 3t squared minus 6t. Now I want to know, when is the velocity 0? Okay, so I'm going to set this equal to 0. So factor that out. So t is equal to 0 and 2. Okay, so now let's go ahead and go with acceleration. So again, remember, acceleration is the derivative of my velocity. So if I take that, I get 6t minus 6. I want to know, when is my acceleration equal to 0? So 6t minus 6 equals 0. I'm going to now you could just solve this. I'm going to factor this out simply because when I plug in numbers, it helps me to see when is it positive, when is it negative. But t is equal to 1. Okay, so now let's go ahead and do our sign chart. And I just do this a little big. So I'm going to erase a little bit of this just so I have more room to write. There we go. Okay, so I'm going to go ahead, do my sign chart. So we'll start with velocity. So velocity is going to be at 0 and 2. Okay, so just gonna, there we go. Okay, so let's go ahead and do that. So at 0 and at 2, my velocity is 0. Okay, so now I want to figure out the signs. So if I'm going to the left of 0, I need to pick a negative number. So I'll just say I pick -1. Well, if I plug in -1 into this equation here, well, I'm going to end up getting a negative times a negative. So therefore that is negative. Again, you're just kind of doing mental math here. Negative times a negative is a positive. Now I'm going to pick a number in between 0 and 2. Remember, you can't include those, so let's say I pick 1. Well, if I plug that in, I get a positive times a negative, so that's negative. And then if I pick a number, any number bigger than 2, let's say 3, well, I plug it in, I end up getting a positive times a positive. So we know that that's positive. Okay, so now let's go to acceleration. Well, acceleration is 0 at 1, so I'm going to notate my 0 here. Well, now I want to do the same thing. So I'm going to pick a value. Well, 0 is a really great number to pick. If I pick 0, I'm going to get a negative number. So it's negative. And then after, let's say I pick a number bigger than 1. So let's say 2. Well, I'm going to get a positive number. So that's positive. Okay. So now I can go ahead and answer the question. So it is slowing down. I'm going to abbreviate here because I didn't leave myself too much room. So it's slowing down on the intervals. Okay, well again, remember it's slowing down where the signs are opposite. So I notice that the signs are opposite from negative infinity to 0. And then I notice that they are opposite from 1 to 2. Okay. Now I'm going to answer where is it speeding up. So these are speeding up on the interval. Again, this is where they're going to be the same sign. So I notice that they're on the same sign from 0 to 1. And I notice that they're from 2 to infinity. Okay, so hopefully you did well on that one. So one more example, kind of the same thing we'll do again. On the AP exam, students are frequently asked to find the time intervals when the particle is speeding up and slowing down and justify your answers. Kind of like what we just did. The only thing we didn't do was justify it, and that would be saying it is speeding up because the acceleration is greater than 0 and the velocity is greater than 0. So we just have to notate that. Sign charts are not scored as justifications by the readers. Okay, so if you do a sign chart and expect and use that as your justification, you won't get credit. They still want you to write a sentence. So kind of like what we talked about in part 1 with that NUT acronym. I want to make sure I'm still stating the reasoning for that. Okay, so while students are encouraged to make sign charts, I really like sign charts. I think they're easy to construct and it helps me visually see what's going on. The justification must be written a bit more formally and reference the comparison of the signs for your velocity and your acceleration. So a particle is moving along a horizontal line with position function s of t equals t cubed minus 9t squared plus 24t plus 4. Do an analysis of the particle's direction, acceleration, motion, and position. Okay, so first thing I'm going to do is velocity. Well, in order to figure that out, the first thing I have to do is find my velocity function. Okay, so that is 3t squared minus 18t plus 24. Okay, well, now I need to go ahead and figure out, well, when is v of t equal to 0? So your velocity is equal to 0 when. So I'm going to go ahead and factor that out. So I can take a 3 out. And then go ahead and factor. So t is equal to 4 and t is equal to 2. Okay? So let's go ahead and do that then. So I have 2 and 4. I'm just going to go ahead and label these. So that's my 0. Now let's go ahead and fill it in. So I need a number less than 2. Well, again, 0 is always really nice. If I plug in 0, I'm going to get a positive number. Again, I don't care what you get. I'm just checking, is it positive or negative? Now I'm going to pick a number between 2 and 4. Let's say 3. And here's where I really like the factor form. I can see that. Well, if I plug 3 in, I get a negative. Here I get a positive. A negative times a positive is a negative. Again, I don't care about the exact value of it. I just want to know, is it negative or positive? Okay, and then let's plug in a number greater than 4. Let's say 5. Again, there I'm going to get a positive and a positive. So that gives me a positive. Okay, so we have our velocity done. And again, you saw probably in the last example, I just did one line with it. You are more than welcome to do one line, or if you want to do them separately to do more room like this one, you can go ahead and do that too. Okay, so let's do acceleration then. So again, that's going to be the derivative of my velocity. So I get 6t minus 18. Okay, so when is my acceleration equal to 0? So I'm going to take 6t minus 18, set it equal to 0. Again, I know that is just like a two-step equation, but I'm going to go like this just because then I can help myself see when I'm plugging in numbers for my sign chart. Okay, so t is 3. That's when my acceleration is 0. So I want to do my sign chart now. So I'm going to pick a number less than 3. Let's say 2. Well, if I plug 2 in, I get a negative. Well, negative times a positive 6 is still negative, so that's all negative. Well, let's pick a number bigger than 3. Let's say 4. Well, that's a positive times a positive. Okay. Now, I'm going to actually answer the question, the motion. So is it slowing up or is it slowing down? Okay, so let's kind of look here. So I have the intervals 2, 3, and those numbers are the important ones. Okay, so that's how I'm going to break up my interval. So from 0 to 2, I'm noticing it's positive and negative. Okay, so again, this is why these are nice. I can really see my work. Well, if there are different signs, that means it is slowing down. So on the interval from 0 to 2, it is slowing down. Okay, well, let's look from 2 to 3. Well, I notice from 2 to 3 that the signs are both negative, so the signs are the same, so that tells me it is speeding up. From 3 to 4, they are different signs, so that means it is slowing down. And from 4 to infinity, the signs are the same, so that means I am speeding up. Okay. And if we wanted to look at the position, so how did this one actually travel? Okay, so again, if I were to take that position function and plug it into my calculator and look at the table, so let's say you want to actually know what all these values are. So 0, 1, 2, let's say 3, S of 4, and S of 5. Okay, so I plug them in, I get 4, 20, 24, 22, 20, and 24. Okay, so let's just see how that would look. So we have 4, and then it's at 20, we'll go 22 and 24. So the particle, I'm just going to go ahead and do this. And here's how it's traveling. Okay. So here's your thing on particle motion. If you have any questions, please let me know.